Hi guys, today we'll be discussing about important topic called page rank. So I'll be explaining what a page rank is. If you go for Google search for any web page such as for any search, let's let's take an example that is television technology. If I go and if I search for any television technology, there'll be a number of web pages will get searches. We'll get a result for the search television technology. There will be a number of pages one by one. How the top is given as a rank one, or the bottom which is under one given as less importance when compared to the top one. How the page rank has been decided, we'll be discussing about that. Let's suppose if you take television technology for example, we have thousands of web pages, but how we'll be ranking those web pages in order to get right information, authority information, how the algorithm is working inside this Google, we'll be discussing about that. Okay, here is a very simple solution that we come up with something called networkx, creating a network. Let's suppose we consider this all these web pages as nodes, and the hypertext, there will be something called hypertext in each and every web page which is connected to another page. That hypertext or else hyperlink, which is known as edge, or a connection between those web pages, and we'll be considering this connection is nothing but an edges, and we'll be creating a huge network where some of the web pages are connected to each other. Okay, we'll be doing that. In order to do that, we'll be following these five important steps. With code, I'll be explaining that. Okay, so first of all, this is Jupyter notebook. Here I'm using Python 7, Python 3. First of all, we have to import a library that is networkx. Then I'll be telling the five important steps right now. Okay, first we have to create a graph or a network which is directional. First point is I'm explaining this as an sample, which is a very simple example how to do it. In real life, we'll be doing the same scenarios with real life data sets. This is just an example. First, create or sorry guys, create or take a directional graph with n nodes. Then second point, that is assign the 100 points to each node. You have to assign the 100 points to each node. Okay, let's suppose take that 100 points to each node. 100 points is nothing but weight. 100 weights to each node. The third point is keep distributing the node, distributing the points until convergence. Okay, this point means that let's suppose I have a node. I have this. Let's suppose I have a one node which is connected to three nodes. This one node is carrying 100 points. So this 100 points must be divided into three groups and share the value to the three nodes which are connected to that node. Okay, simple. Suppose we'll take one node is connected to three nodes. I mean three nodes. We have to pass this 100 points to, we have to share this 100 points to three nodes equally. The process will continue. I mean the process will continue until the convergence. I mean uh, if there is no change after some iterations, there will be no change in there will be no change in the points at this nodes. That point is known as convergence. We have to do this distribution until the convergence. Then next we have to get sorry get the ranks, thus obtained with accumulated. That is, we'll be getting different points for each of the node, and we'll be deciding which node has the highest points. That consider that node as holding the page rank as one. I mean to say the rank as one. Then at last compare the ranks with the inbuilt page rank method. In this tutorial, in this library, there is something called inbuilt page rank method. At last will be this conventional method. This is automated. The page rank is some function which is written in networkx. We have to do this conventionally, and we have to compare this value with the inbuilt page rank method. Okay, we'll be doing that. First, the thing is we have to create directional graph. For that, I just want to write the function, that is main function. Okay, then I have to create this graph is containing nodes and edges. Okay, g is equal to, I am creating empty graph, x dot digraph. Then I have to add the nodes, add nodes from. I'm coming to only 10 nodes. So the nodes are created, and we have to create edges. Edges, we can create the edges to each of them. To the each. I mean, the edges can be created. All the edges can be created, but we just want only some of the edges which are random in nature. For that, we have to go for something called a function. I am creating one more function here, add edges, and here I am passing something called g, that is graph, and this is called point 3 is nothing but p value, that is probability value. It's something like tossing a coin. If the after tossing a coin, if the coin is head, then we are adding those edge to the adding the edge, particular edge. If it is a tail, we are not adding the edge to the graph. Okay, G comma P. Here we have to do something called, here I am deriving each and every node. So each and possible edges, each and every possible edges. If you see here, I and J, I comma J are the possible edges, all possible edges of this graph. For us, we don't want that. We want something called probability, and we have to check this statement. If I not is equal to J, then we have to go forward. Then we have to create something called the random variable. For that, I have to import the random library, random module. Here you can see we have to create a variable with the random. So this will return the value from 0 to 1 if r is less than or equal to p. Then what we have to do? We have to add edge. Dot add edge. We have to add edge, that is I comma j. The value is, we don't want to do anything, that is continue. Continue. Okay. First thing is we have done with creating a graph, that is here I mean to say return. Okay, successfully we have created a graph. Second one is this one, assign 100 points to each node. Okay, then let's suppose we have these points. We have to initialize these points. Initialize the points. We have to give the graph. Okay, then again how to create the function called initialize. I'll be getting the graph as an input for points. See, for each and every node in this graph, I am assigning the value as 100. Okay, points is equal to 100. Sorry, return is equal to 100. Sorry. As you can see here, we have created a graph, and we second point we have assigned 100 points to each the node. Okay, let's see the graph and 100 points as a list. Okay, to do that, here we have to return something called index.draw. that is g comma points. Sorry guys, it's my mistake. Is not for, it is if. I have to call the function. So here you can see here, this is a graph of holding 10 nodes, and this is a directional edges. See, I have initiated 100 to each the node, and I have to distribute the values to each and every. Successfully, we have completed 2 points. The next point is keep distributing points until the convergence. First, we have to define a function for distributing the points. It is a sub in that. Okay, distributing the points. Def distribute. We'll be getting nodes, comma previous, comma points. Let's say previous points. Previous points is nothing but the points. You can see here we have initialized these points, no points for each and every graph. That is 100, 100, 100. That is previous nodes. Here we have to do something called initialize new points. New points is equal to 0 for I in g dot range g dot number of. Here we have initialized the new points. Okay, then the thing is, for each and every node in a given graph, we have to check the connections. I mean, the connections are outages. For I in g dot node, see here, this outages, function returns the number of connections, the number of connections this I node have. Okay, this is only applicable. Out edges means how many outcoming edges are there from this node. This can be, this function is in the only in digraph, that is directional graph. Okay, see here we have got something called out. Suppose, consider this point, if the node has no edges, out edges. For that, we'll do like this. If length of out double equal to 0, then what we have to do? We have to do something like this. Previous points, new points of particular I plus equal to previous points of I. Why? Because we are transforming each and everything to the new points list. Okay, we are forgetting the previous points. Okay, then else we have to share. We have to share. Uh, let's suppose the node is containing 100 points. We have to share this 100 points to outcomers. Depends upon the length of that out. Okay, share that is equal to previous points of I, that particular node, divided by length of out. So we'll be getting this share value for each and every node, where we have to share this value to the out edges of that particular node. Okay, then what we have to do, we have to do for each in, for each in out g dot, sorry, previous points bracket each, that is dot one. Here you can see I am the previous points of this node. One is nothing but index, is nothing but the value. Zero is nothing but which represents the name. One is nothing but index of this each node, and the previous value is plus equal to share. Okay, I'm sorry, I said no. These new points, new points. Why? Because we, I said to you already, I'm transforming everything to new points. Okay, then we are done with this. Then what we have to do, we have to return g comma new points. Okay, see here, I'll call this function. We have did this function distribution is equal to distribute. Then what we have to give there, that is graph comma previous point, that is points. Here we have to return distribution. Here you can see this is a transformation. This is a transformation in the each and every node. Here the second node is 0. The first node value is 145, and the third node value is 125, 20. This transformation took place. Okay, what we have to do, we have to transform this whole data set, I mean whole list, until the convergence, until there is no there is no value to change. I mean the precision will take place, the repeating the same values. Okay, you have to do that. That is 4 point. Keep the convergence. Okay, right now we will delete this. We have to add we have to create this function, that is make converts. We'll be passing this g as command, and we'll be passing these points. Okay, we have to do this distribution function many more times in order to get the conversions. I'm writing this deriving this the conversions, this g comma points. Okay, then for namesake, this previous points is equal to points. For is, in order not to get confused, here that is previous points, we have to derive new points. From this we'll be getting new points. Okay, that is g comma new points is equal to distributes, uh, that is we have to pass g comma previous points. This has to be done iterative steps, hence we will be putting while loop, while one. When we have to stop, so we'll be giving this function to user itself. Let's suppose write this print type has to type has to stop the code. Okay, here char is equal to int if char double equal to hash. We have to break this loop. One more thing, that is for this we'll be getting previous points, and we have to tell that previous points is equal to new points. To continue this, previous points is equal to new points. For each and every iteration, this previous points will keep on changing, new points will keep on changing. Hence, we have to derive this previous points is equal to new points, and the last we have to get, we have to return g comma new points. Okay. So we'll call this as converge converge. So go to make converge for these g points. We have to return this converge. Okay. So it is asking for type slash to stop the code. I don't want to stop the code. Sorry. I'm sorry, there's some problem. Yes, here it is working perfectly. But I have written the return statement, but I have not printed each and anything. Here I am doing something called the print statement. I'm writing that to print a new points. So you can see now it's going to print the points. Unbound local. You can see here I said I have to write the print statement. Here you can see how to I am writing the print new points. After going through this function distribute, I'll be getting new points. So if I print this, you can see I'm getting the values for each and every node. If I want to continue, I have to press any other key. Here you can see the values are different for each and every direction. We have to do until how many times we want. Then we have to press something called hash in order to stop the code. Okay. The next two steps we'll be discussing in our next video. Thank you.